Hello and welcome back to the Exam Tomorrow series, Lecture 5, Differential Equations. So in this video, we are going to talk about Clairaut's form. Let's take a look at how things are going to work. If we have a differential equation which can be exclusively arranged in this format, y equals to p into x, where obviously p stands for dy dx, plus some function of p where x and y are not supposed to be involved. So y equals to px plus any random function of p. If we can arrange the differential equation in this format, then this format is specifically called Clairaut's form, and from here we get two kinds of solution. One is a general solution and one is a singular solution. So let's get a brief idea of what is the difference between a general solution and a singular solution. First, let's take a look at our first question. In Clairaut's form, typically the question asks to find the general solution as well as the singular solution of the given differential equation. So whenever you see a question is asking for singular solution, you must know that it is definitely a Clairaut's form equation. Okay, now let's try to understand the difference between a general solution and a singular solution. So when we plot the solution of a differential equation, let's say we are plotting a general solution as well as a singular solution. General solution is that particular solution which contains the integrating constant, which is the c term, which is the constant term. So for different initial values, the c constant value will keep on changing. So if we start plotting for different initial conditions, correspondingly we get different c values, we get trajectories like this, which is in the yellow color. So this is representing the family of solutions. Okay. Now singular solution is that particular solution which never arises in the general solution. That means any value of c cannot create that particular solution, but the singular solution is kind of an envelope of the general solution. That means in this diagram, this blue curve, this is the singular solution. We can see it's kind of an envelope of the general solutions. That means it is tangential to each of the general solution. It touches all the general solution at some point, but the general solution can never create the singular solution, and the singular solution obviously satisfies the given differential equation. So this is the diagrammatical representation of general solution and singular solution of a given Clairaut's form differential equation. So I hope you got an idea how things are going to work. So basically in a singular solution, there is not going to be any constant term involved. In general solution, we will have constant term. This is the important thing to remember. No constant in singular solution because it's a fixed solution. It doesn't change. General solution will be dependent on the integrating constant c. That means for different value of constant, we will get different trajectories, which in general represents the family of trajectories. Okay, so let's get back to our question. So it's asking that we need to find the general solution as well as the singular solution. First of all, we need to express this in our Clairaut's format, which is y equals to px plus function of p. So what I'm going to do is y minus px, I'll multiply this factor on the other side, so p upon p minus 1. And now if I bring the px term on the right side, so y equals px plus p upon p minus 1. So I can see this is in my format y equals px plus function of p, right? So my function of p is this part, as we can see. The moment we have got it in our required format, now the process is we have to differentiate this both sides with respect to x. So differentiating this both sides with respect to x, dy dx equals px, we will do a product rule, so p plus x dp dx, and then we have to do a division rule for the p by p minus 1 part, so that would be p minus 1 derivative of p, that would be dp dx, minus p into derivative of p minus 1, that would be again dp dx, divided by a p minus 1 whole square, right? Now what we can do is, in place of dy dx, we can write it as p. So this is p equals p plus x dp dx, plus we can take a dp dx common from this part, and we can see this p and this p would get cancelled. So basically we'll just have a minus dp dx divided by a p minus 1 whole square, right? And also we can see the two p terms are getting cancelled. Now this will always happen in a Clairaut's form differential equation. When we proceed in this way, we will see the dp dx term can be taken completely common from the entire equation upon cancellation of terms. Okay, this will always happen. Okay, so now what we can do is we will be taking dp dx common, and we are having x minus 1 by p minus 1 whole square. So from here two possibilities are going to arise. The first is dp dx can be 0, and the second is x minus 1 upon p minus 1 whole square equals 0. So this portion is always going to arise. Remember this, whenever we are solving differential equation, this will always arise irrespective of the question. This part will keep on changing. Now keep in mind, this will give us our general solution, and this part will give us our singular solution. Okay, so the general solution will be always same, doesn't matter how the question is going to be. So if we integrate this both side, we get p equals to some constant c. So now we are just going to place this value of p in the given question. That means we are going to replace p with the constant c, and that's going to be our general solution. Now for every Clairaut's form equation, always remember that this is always going to arise p equals c. You replace the p term with the constant c term, and that's our general solution for a Clairaut's form. Okay, that's simple. Now for the other part, we would like to express p in terms of the other terms that are present, and then put the value of p in the given question. So we would have p minus 1 whole square equals 1 upon x. So p minus 1 would be 1 upon x under root x with a plus minus sign. So p would be 1 plus minus 1 upon root x. So now we are going to put these two values of p in the given question. Okay, so instead of taking the original question, let's put the p value in this form that we have got, y equals px plus p upon p minus 1. So we had already got the format y equals to px plus p upon p minus 1. So let's put the values of p respectively. So over here, if we put p equals c, then the solution that we are going to get is y equals to cx plus c upon c minus 1. So this is our general solution, and as I showed you in the diagram, if you change the value of c, you will get different trajectories, which represents the family of curves. Okay, now if we are going to put this particular value p equals 1 plus minus 1 under root x, and then simplify this a little bit, then we are going to get our singular solution. So let's quickly do that. So y equals 1 plus minus 1 upon root x whole into x plus 1 plus minus 1 upon root x by 1 plus minus 1 upon root x minus 1. So we can see the minus 1 is getting cancelled, and if I multiply this x term by term, I'm going to get x plus minus root x plus there is a plus minus here as well. So plus, if I take the plus minus common, if I take this plus minus common, then I have 1 divided by 1 upon root x, so that's root x, plus minus 1 upon root x by 1 upon root x, that's a plus 1, plus minus 1, right? So now I have plus minus root x, and plus minus multiplied with a plus minus, that will become a plus, so plus 1. So that means we are having y minus x minus 1 equals plus minus 2 root x. Now as I said, I just wanted to get rid of the plus minus, so I will be doing a whole square both sides, and that would give me y minus x minus 1 whole square equals 4x, and this is where I will stop, and I will say that this is my singular solution, and that's our final answer. Okay, so there we have our general solution, and this is our singular solution, and that's the answer to the Clairaut's form question. Okay, let's take a look at another question. question number 2, which is in this form, and as you can see it is asking for a general solution as well as a singular solution. That means it is definitely a Clairaut's form question. We just need to express it in the required form. We can see y over here, which is inside cos, so we need to bring it outside cos. So let's take a cos inverse both sides and we get something like this. Then we can write y equals px plus cos inverse p. So this is definitely of the form y equals px plus function of p, right? So that means this is in our Clairaut's format. We can now start by differentiating both sides with respect to x. So if I do that, now I'll do some step jumps. Derivative of y with respect to x, that's dy dx. dy dx I'm directly going to write as p. Okay, so here another product rule that would give me p plus x dp dx, and derivative of cos inverse is minus 1 upon root over 1 minus p square and followed with a dp dx. So what happens, p gets cancelled, and just like I told you before, dp dx can be taken completely common. Okay, so if I take dp dx common, I get x minus 1 upon root over 1 minus p square equals 0. So two possibilities start from here. Either dp dx is 0 or x equals 1 upon root over 1 minus p square, right? From here we get the same old value, which is p equals constant, which we are going to put in the given differential equation and get our general solution. And from this part we would like to find the p value. So 1 minus p square, that would be 1 by x square. So p square would be 1 minus 1 by x square, and p would be plus minus root over x square minus 1 whole by x. So these are the two values that we have got, and we would like to put these values in this differential equation and get our respective answers. So let's quickly do that. So if we put p equals c in the given differential equation, we get y equals cx plus cos inverse c, and this is our general solution, right? Now if we put this in the given differential equation, we are going to get y equals px. So if I multiply this with an x, so the x in the denominator gets cancelled, so I just have a plus minus root over x square minus 1 plus cos inverse of p, which would be plus minus root over x square minus 1 upon x, right? Again, I don't want a plus minus in my answer. I want to get rid of that by doing some simplification and whole squares. So let's see what can be done. I'll bring this term on the left side. So 1 plus minus comes on the left side, so it becomes minus plus root over x square minus 1 cos inverse plus minus root over x square minus 1 upon x. So I need to get rid of the cos inverse first. So let's do that. So cos of y minus plus root over x square minus 1 equals plus minus root over x square minus 1 upon x. So let's do a whole square over here, and we would get cos square y minus plus root over x square minus 1, that would be x square minus 1 upon x square, right? And this we can write as 1 minus 1 by x square. So what we can do is we can write 1 minus of cos square, right? If I take this term on the right side, so I'll get 1 minus cos square, so that becomes sine square, and I'll bring the 1 by x square on the left side. So 1 by x square equals sine square y minus plus root over x square minus 1. Now I don't think this plus minus can be removed. We had two plus minus signs, we removed one of them, one is still remaining, so I don't think this can be further simplified. So let's keep it like this, and we can say that this is our singular solution. Okay, so we have got our general solution and this is our singular solution, right? Let's do one last question. So this is the given differential equation. First of all, we need to bring this in the Clairaut's format. So we have y equals x, dy dx can be written as p So this is already in the Clairaut's form, right? So we'll directly start differentiating both sides with respect to x. So that will be p equals x plus p plus x dp dx. Derivative of p square would be 2p dp dx. So it's again all the same, the p gets cancelled, the dp dx goes common, and we have x plus 2p equals 0. So two possibilities, dp dx 0, and p from the other part we would get p equals minus x upon 2. So from here p equals c, which is the usual case, and from here p equals minus x by 2. So let's put this in our differential equation. If I put p equals c, I get y equals xc plus c square, and this is my general solution. And if I put the other thing, I get y equals x into p, that would be minus x square by 2 plus p square will be x square by 4, right? So this would be y equals minus x square by 4, and this is my singular solution. And now the best thing is the two solutions that we have got, these two solutions, if I plot, then this is the diagram that we get. So this diagram corresponds to the solution of question number 3 that we did just now. If I plot all the general solutions with different values of t, these are the straight lines that we get. And if I plot the singular solution, which was y equals minus x square by 4, then this is the parabola that we get, which is our singular solution. So basically this diagram represents this solution that we did just now, right? So I hope this makes sense. Thank you for watching. See you in another video.